Hello everyone, myself Sneha Murthy, studying in Sri Venkateshwara College of Engineering from ISC branch. Today we are going to discuss a subject called Oops with Java, and the topic is Autoboxing in Java. Here the first is Introduction to Autoboxing in Java. Autoboxing is a feature in Java that allows automatic conversation between the primitive types and their corresponding wrapper objects. This feature was introduced in Java 5 to simplify the coding and improve readability. Autoboxing eliminates the need for manual conversation between the primitive types and their wrapper objects. Here, the autoboxing in Java contains boolean, byte, char, float, int, ong, short, and from this side we can see the boolean, byte, character, float, integer, long, and the short. These are the things which we can contain in autoboxing and unboxing. This is the introduction to autoboxing in Java. Next is autoboxing of primitive types. Autoboxing automatically converts the primitive types such as int, float, or char into their corresponding wrapper classes like integer, float, or character. This conversion happens implicitly without the need for explicit casting or conversion methods. For example, an int can be assigned to an integer without any explicit conversion. Here, autoboxing implicit conversion between the wrappers and the primitives. Here we can see the example, that is import java.util.arraylist, public class basic array list, public static void main string args, array linked list is less than integers, which is greater than L, that is equals to new array list less than integers, which is greater than long dot add, that is we have given a number 5 and 6, integer first value is equals to L dot get 0, and we have to close the bracket. Code above works even though we're passing into a and adding and assigning a return value of a type integer to an int. This is an autoboxing of a primitive type. Next is unboxing of a wrapper objects. Unboxing is the opposite of autoboxing, where a wrapper object is automatically converted back into its corresponding primitive type. Unboxing allows you to use the wrapper objects as if they were primitive types. For example, an integer can be assigned to int variable without any explicit conversion. These are the things: boolean, character, byte, short, int, long, float, double. These are the wrapper classes which is used in autoboxing and unboxing also. Here we can see the autoboxing and unboxing examples. For autoboxing, int num equals 10 and the integer object equals num. For unboxing, integer object is equals to new integer of 20. Int num equals object. Here we can see in this box, that is they have given a list integer values, that is equals to new array list of integers values. Int value is equals to values dot get 0, and integer value and int primitive. Here boxing and unboxing, value equals primitive for boxing, and for unboxing primitive equals value. And this is an example for an autoboxing and an unboxing. And the next is performance considerations. Autoboxing and unboxing can have an impact on performance due to the creation of a temporary objects. Frequent autoboxing and unboxing can cause the unnecessary object creation and the memory allocation. It is advisable to avoid the excess autoboxing and unboxing in performance critical selection of a code. Here they are saying that we have to avoid the excessive autoboxing and unboxing in performances while the critical sections of a code. This is all about the performance considerations. Next is autoboxing and the collection frameworks. Autoboxing simplifies the usage of the primitive types in the collections, which primarily work with the objects. Collections such as array lists or hash map can directly store the primitive types without the need for manual conversion. This improves the code readability and reduces the amount of boilerplate code. Here we can see the table that first is iterable collection queue. In the collection that is of list, queue and sets. In lists, array list, linked list, vector, stack. In the queue we have priority queue and deep queue and array queue. In the set there are hash set, linked set and sorted set. This is the table which we can see for the auto boxing and the collection framework. Next is null values and auto boxing. Auto boxing can lead unexpected behavior when dealing with the null values. If a null value is assigned to a wrapper class, it will result in a null pointer exception when trying to unbox it. It is important to handle the null values approximately to avoid the runtime errors. This is all about the null values and the auto boxing. Next is auto boxing and the method overloading. Auto boxing plays a crucial role in method overloading where the methods can have a different signatures based on their parameter types. Auto boxing allows the method to accept the both primitive types and the corresponding wrapper classes as arguments. This simplifies method calls and enhances the code flexibility. Example of function overloading. Here we can see the example of a method overloading using autoboxing. Next is autoboxing limitations. Autoboxing is limited to a specific set of primitive types and their corresponding wrapper classes. It doesn't work with the custom classes or other non-primitive types. For custom types, manual conversion methods or the constructions need to be implemented. For custom types, manual conversation methods or constructions we have to implement. The manual conversations and the constructions we have to implement. This is the limitation about the autoboxing. Next is best practices of autoboxing. Use autoboxing sparingly, especially in performance critical sections of a code. Be aware of a potential null values when dealing with autoboxing. Avoid autoboxing when working with the custom classes or non-primitive types. These are the best practices of autoboxing. And the benefits of autoboxing are it simplifies coding by eliminating the need for the manual conversion between the primitive types and their wrapper classes. It improves the code readability and reduces the amount of boilerplate code. It enhances the flexibility in method overloading and the usage of the primitive types in the collections. So these are the benefits of the autoboxing. Next is drawbacks of autoboxing. We can performances implications due to the creation of a temporary objects. Handling null values requires careful considerations to avoid runtime errors. Limited to a specific set of primitive types and their corresponding wrapper classes. Next is example code snippet. Integer num equals 5. Integer num equals 5 is autoboxing. Int value is equals to num. This is unboxing. And system.out.println value is the output is 5. Autoboxing comes to rescue. This is an example that is of class menu, open the bracket, class main, open the bracket, public static void main string args, that is boxing, integer a equals 2, and the unboxing int s equals 5 plus a. We have to close the bracket. Next is the conclusion. Autoboxing is a powerful feature in Java that simplifies the usage of the primitive types and their wrapper classes. It improves the code readability, reduces boilerplate code, and enhances the flexibility in method overloading and the collections. Care should be taken to handle the null values and consider the performance implications. This is the final conclusion about the autoboxing in Java, and thank you.